Assalamualaikum warahmatullahi wabarakatuh and good day. I'm Dr. Siti Rabiatul Aisyah binti Idris, will be your lecturer for today's lecture, and this is PMM 1533, Strength of Materials 1. Today we are going to continue with our topics, which is CO3 and pure bending. So the objective for this topic is to analyze the stresses and strains problem in members subjected to pure bending and transverse loading, whereas for lesson objective for the subject is stated such as follows. So for today, we are going to look at on the example from our previous lecture, which is lecture 11 on concrete. Okay. So let's read this example together, the question together. A concrete floor slab is reinforced with 16 mm diameter steel rods. The modulus of elasticity is 200 gigapascal for steel and 35 gigapascal for concrete, with an applied bending moment of 4.5 kN for 0.3 width of the slab. Determine the maximum stress in the concrete and steel. So question asks you to select only 0.3 meter, or in other words, and 300 mm. So from this point until this point, or this point until this point. So 300 mm only. So how to solve this question? First of all, we need to transform the section made entirely from concrete. So, and we can get the value of N equals to E steel divided by E concrete, which is 200 divided by 25 equals to 8. So, the area for steel now is changing. So, what is the new value? NAS equals to 8 here, N for 8 times with 2 16 mm power of 2 pi divided by 4 and equals to 3215 mm square. So this is the transform section for steel. Alright. Now the second step is we need to evaluate the geometry properties of the transform section. If you still remember our formula in previous lecture, so we need to take a moment at neutral axis line, 300 times x, because this is the area for upper part here, section here, times with centroid to neutral axis distance, x divided by 2, times with transform section here, 3216 times 100 minus x equals to 0. So now you'll get the value of x is 36.8 mm. From there, using a formula for moment of inertia, BH cubed over 3. So from there you get the value of I equals to 17.8 times 10 power of 6 mm power of 4. After that, calculate the maximum value of stresses. For concrete, sigma equals to my over I. 4500 Newton meter times 0.0368 divided by the value of moment of inertia that have been calculated. So we'll get sigma for concrete is 9.286 megapascal, whereas for steel, so this one, for this case, you cannot straight away times value of N with stress for concrete, because the location is changing for this one, and therefore you need to find the value of C2, which is equals to 0.06 32 meter. Only then you can substitute into the formula. You'll get the value of stress for steel is equals to 127.5836 megapascal. Okay. How do you find the value of 0.0368 here? Or how do you find 0.0632 here? So it comes from value of x here. If you refer it back from this calculation, then you'll get the value of C1 and C2. Alright, so this one is for C1 and the lower part is C2. Okay. So the next section is on stress concentration. Same goes to our previous lecture. Always do not forget on stress concentration, because not all parts sometimes we don't want to neglect the stress concentration or value of K there, and therefore we need to include the calculation of stress concentration in our solution or in our calculation. So how to find the value of K is depending on the component or members that is being given to you, and of course the table, its own tables, and therefore you will get to find the value of K. So how to include value of K in our calculation is the same, whereby we just times with value of concentration into our flexure formula, which is sigma equals to K times with my over I. Alright. So from here, I would like to give you an exercise. Please do this exercise and submit before the end of this class. So I think that will be all for today's lecture. Hopefully we'll meet again by next week. And if you have any question related to this topic, please, do not hesitate to contact me. It's either in a group or you can email the question, and I'll come back to you as soon as possible. With that, I would like to thank you very much for your kind attention and time. So we meet again in the next lecture. Have fun and goodbye.